Continuing on with our theme of systems of equations, we're going to look at a system with three variables. So in Math 1, we solved for two variables, x and y, and we had two equations. Well, now we have three variables, so we're going to have three equations to solve. Okay? So what we're looking for is where x, y, and z are always equal in each equation. Okay? So what we're looking for is a coordinate pair, but in this case it's a little bit three-dimensional. So we're going to go x-axis, y-axis, and the z-axis. So what we're going to do is we can follow this pattern almost every single time we solve our systems with three variables. Okay? So the first thing we're going to do is we're going to pick a controlled equation. So it's going to be our control. You'll kind of understand what that means here in a second. So if I kind of look at my numbers here, I like the way that this x is just a solo x. So I'm going to go ahead and pick this as my control function. Okay, so that's my first step. Pick a control function. And what we're going to do with this function is we're going to use it so we can eliminate one of the variables from our other two functions. Okay, so I'm going to use my control function to eliminate x. So my second step is we're going to eliminate one variable, the same variable, from the other two functions, or the other two equations. Yeah? Okay. So how we're going to do this is I need them to have equal coefficients. So if I take this function and I want it to have the same coefficient here, I want it to have a 4, I'm going to take this bottom function and I'm going to multiply it by 4. So we have the negative 4x minus 6y plus z equals negative 20. And now I'm going to multiply this entire function by 4 so my x's have the same coefficient. So that's going to give me 4x minus 12y plus 20z equals negative 28. Okay, now that they have the same variable, or the same coefficient, one's positive, one's negative, I'm going to add these two equations together to eliminate my x. So negative 4x plus 4x, that gives me 0x. Negative 6y minus 12y is negative 18y. 1z plus 20z, that's 21z. And then negative 20 and negative 28 is negative 48. So now I only have two variables. Make sense? So we're going to do the same thing to our second equation. We're going to eliminate x. So we have negative 2x plus 3y plus 2z equals 23. And I want my x's to have the same coefficient, so I'm going to multiply it by 2. So I'm going to get 2x minus 6y plus 10z equals negative 14. Okay, and again, I'm going to add these together. So that's going to give me 0x, negative 3y plus 12z equals 9. All right, now we're back to Math 1 level. Okay, we have two equations, two variables. So my third step is using my two equations, I am going to eliminate a second variable. So now I could go ahead and get rid of my y's or my z's. So I'm going to go ahead and rewrite them over here. So I have negative 18y plus 21z equals negative 48. Then I have negative 3y plus 12z equals 9. So again, what I want is one of my coefficients to match, so we could go ahead and eliminate that variable. So what I'm going to do here is I'm going to actually make my y's match, since that's going to be an easier multiplication. What I'm going to do is I'm going to multiply this by negative 6. So my signs are opposite, but my coefficients are the same. So I'm going to take negative 3y times it by negative 6. It's going to give me a positive 18y. Negative 6 times 12, that's negative 72z. And negative 6 times 9, that's negative 54. So now when I add these together, I get 0y, 21 minus 72. So that should be negative 51z equals, and then I have 48 and 54. They're both negative. That gives me negative 102. So now that I've eliminated that second variable, well, now I'm ready to solve for the third. Okay, so 1, 2, 3, my fourth step, solve for the third variable. So I'm going to go ahead and divide by negative 51. So I'm getting z equals 2. That's it. Now all I'm going to do is I'm going to go ahead and I'm going to back solve. I'm going to substitute in, I'm going to solve for y. So if z equals 2, I can plug that in here. So negative 3y plus 12 times 2 equals 9. So that's negative 3y plus 24 equals 9. So I'm going to minus the 24 over. So negative 3y equals negative 15. And I get y equals 5. So now we have y, we have z. My last step is to solve for x. So I could come in and I can plug in here. So I'm going to have x minus 3 times 5 plus 5 times negative 2. Nope, it's just 2. Yep, just 2 equals negative 7. So x, that's negative 15 plus 10. So that's x minus 5 equals negative 7. So if I add the 5 over, I get x equals negative 2. So what we're going to see here is my answer is going to be negative 2x, 5y, and 2z. If you follow this process every time, it's going to work out. The thing is, we might have to multiply both functions to make them match. We might not have to multiply either function to make them match. But as long as we can get those matching coefficients so we can eliminate, if they have the same sign, you're going to eliminate by subtracting. But if they have opposite signs, we can eliminate by adding. Okay, you got practice examples on the homework. Go ahead and check those out. If you need help, let me know. Mel?